So my name is Girish Narayan Prajapati, and I have already on the subtitles. So you can see the subtitle at the bottom of the presentation. It is in Spanish. So
Yeah.
the presentation is about the use of fiber reinforced polymer bar in civil infrastructure. So the presentation will contain introduction, little bit about the FRP bar, its application, and one case study and conclusion. This presentation will take only hardly 15 to 20 minutes only.
Vamos a tomar en esta presentación de 15 a 20 minutos y luego continuamos con imágenes y demás.
Our products, which is SFTec-Bar products, are generally designed in Canada at Sherbrooke and Montreal, and those are manufactured in China by Sandox Safety Industry Co. Limited, and those are specialized in manufacturing of fiber reinforced polymer products. They not only produce the fiber reinforced polymer bars, they also produce the fibers for concrete and pipes and other products also. So generally we work with the national and international engineering firms, and we work in the parking facilities, water treatment plants, and retaining walls. And we are focused are generally on the FRP bar market and the carbon strap applications. So in generally the SFTec bar is made of from composite materials, fiberglass and carbon fiber, and it is manufactured by a pultrusion process using a mixed of recycled fibers and resin. And the figure here, you can see the microscopic view of the fiber reinforced polymer bar. This is the interface where you can see this is the epoxy and these are the glass fiber or carbon fibers, whichever you are using. So there are three different types of FRP bars available in the market: carbon, amarite, and glass. And also there is another one on which the research is going on, which is made from basalt. And the stress strain curve plot shows how these fiber reinforced polymer bars compared with the steel bar. So 2 points should be noted from this plot. The first, the glass fiber reinforced polymer bar have lower strength compared to the other two fiber reinforced polymer bars. And second, the strength of all fiber reinforced polymer bars are higher than steel bar. However, their behavior is linear, elastic up to failure. And these are the products generally produced at the SFTec. And those some of the FRP bars, those are produced are the straight bars, spiral, stirrup for transverse reinforcement, bent bars, and glass fiber reinforced polymer shear connectors. The glass fiber reinforced polymer bar is widely used due to its production cost and have better tensile strain compared to other fiber reinforced polymer bars. So FRP bar offers many advantages over the conventional steel, and some of the advantages are listed here. They have longer service life because of its corrosion resistance and improved durability in harsh environments such as construction near coastal area in northern American cold climate. The FRP bar have better resistance against corrosion compared to steel bar. And as I told earlier, the tensile strength of FRP bar are 2 to 3 times more than that of the steel bar. However, it have more tensile strength. FRP bars are lighter due to low density compared to steel bar. And due to the corrosion resistance, fiber reinforced polymer bar are good for harsh chemical environments as well. And it is also neutral to the electrical and magnetic disruptions, useful for the applications such as airport, military applications, MRI rooms, and hospitals. So these are the some of the selected field application of the SFTec fiber reinforced polymer bar, which we have already done in Canada. So you can see in the figure, it's the GFRP reinforced concrete waffle flooring slab designed with aseptic glass fiber reinforced polymer bar. And this was built in Halifax, Nova Scotia. And it can be used for slabs on grades. And it is a non-structural slab, and it was a one-to-one replacement. And it saved a lot of money compared to the steel bar in terms of labor and transportation because of the lighter weight of the FRP bars. Another project shows the cast on site precast sandwich panels, and they have used our glass fiber reinforced polymer bars in their project as reinforcement. And in the right side, you can see the retaining wall built for the city of Montreal. And the retaining wall is designed to dump snow with de-icing salt during the winter. And they built they built this retaining wall with aseptic glass fiber reinforced polymer bar, which provided resistance against the chemicals used in the de-icing salt during the winter season. I think everybody know what is the process of corrosion. So here is the small video which shows how the corrosion occur. The corrosion generally occur due to the alkaline environment of the concrete. which generally provide a proper protective layer against the corrosion of the steel. But there is a presence of chloride ions in de-icing salt and seawater, which reaches the steel reinforcement through minor cracks. And once it exceeds the threshold limit, it can induce rusting of the reinforcing steel. The rusting generally causes expansion of the steel rebar, and it's create tensile stresses in concrete, which lead to cracking, delamination, and finally spalling of concrete cover. So generally what will happen, there will be loss of serviceability, and concrete structure will require maintenance earlier than the expected. So these are the some of the highway bridges, which are the examples of the corrosion of the steel bars. So this thing I have already told you about the advantages of the FRP bars and why should we use FRP bar. So generally because of the it provide resistance against moisture, alkali effects, and chemical attacks. And in addition to that, FRP bars are lightweight and non-conductive and magnetic free. So generally the SFTec FRP bar properties, which is only given for the glass fiber reinforced polymer, the size available sizes are in 6 millimeter to 35 millimeter, and their cross section varies from 32 to 1006 millimeter square, and the tensile strength varies from 700 to 1100, but it is written for the minimum guaranteed tensile strength, but actually the tensile strength can be more than 1400 or 1500. And the elastic modulus, the tensile modulus generally varies from 46 to 70 megapascal. And based on the elastic modulus, 40, 50, and 60, these are grouped into three different types of SFTec bar. And because there is a variation in the types of glass fiber used, there are very different types of glass fibers are available in the market, like structural glass fiber or electrical glass fiber or chemical glass fiber, or there is a strong glass fiber is also available, which varies the tensile modulus. In addition to the amount of fiber we are giving, the percentage of fiber content in the bar will also influence the tensile modulus of the GFRP bars. So the advantages of the GFRP bars is that its tensile strength is twice that of the steel bar, but the weight is almost 1/4 times the or quarter the weight of the steel bar. There is no electrical conductivity, and there is no salt water deterioration, and you can save a lot of money in the labor and transportation. So now coming to the design philosophy of the fiber reinforced polymer reinforced concrete structure. So we already know that how we already know about the design philosophy of the steel reinforced concrete structure. So generally there are three different types of design philosophy. One is called balance section, another is under reinforced section, and the last one is the over reinforced section. So the steel reinforced concrete structure generally follows under reinforced section, where the failure occurred due to the steel failure, and which can provide ductility to the structure, or in other words, we can say that we have the time before the collapse. So following the under reinforced section, the fiber reinforced polymer reinforced concrete structure will have fiber reinforced polymer bar rupture before the concrete, and which will be not suitable for the structure, because the structure may fail in the brittle manner, because the fiber reinforced polymer are generally linearly elastic. They have stress strain profile linearly elastic. So therefore, to avoid this kind of situation, the over reinforced section is considered for the fiber reinforced polymer reinforced concrete structure, and where we generally prefer the concrete crushing should occur before the fiber reinforced polymer bar failure. So which will provide some inelasticity to the structure. So based on the ACI 440 and CSA ACE 806 code, there are some design assumption where we can say the plane section before before loading remains plain after loading, and this is true for both steel reinforced concrete structure and the fiber reinforced polymer reinforced concrete structure. So here the compressive strength in the concrete is around 3000 microstrain, according to the ACI 440 and 3500 microstrain according to the Canadian code. The rupture strength of the concrete is very low, so it should be ignored in the design. And finally, the considered tensile behavior of fiber reinforced polymer reinforcement is linearly elastic until failure, and we assume that a perfect bond exists between the concrete and the fiber reinforced polymer bar. So now coming to the application of the fiber reinforced polymer bar, where we can use these bars. So we can use in any harsh environment where the structure is susceptible, structure is subjected to corrosion by chloride ions or chemicals, and any concrete structure requiring non-ferrous reinforcement due to the electromagnetic consideration, and as a cost-effective alternative to epoxy-coated or and galvanized steel bars, and it will save a lot of money over the stainless steel bars for reinforced concrete members in tunnels and minings where the presence of moisture is more in the earth, for structure which require thermal non-conductivity, and finally in mass concrete exposed to marine chlorides near the chloride exposure in hybrid applications with steel bar. So let's talk about some of the application of the fiber reinforced polymer bars, which is already conducted since 1999. So it was used in the bridge deck slab in North America countries like United States and Canada. The glass fiber reinforced polymer bars were preferred because of its low cost compared to other available fiber reinforced polymer bars. And here are some of the examples of the bridge deck slab constructed with glass fiber reinforced polymer bars in Pierce Street Bridge, Salem Avenue Bridge, and de la Cruz Bridge. The precast bridge deck slab was used in the Emma Park Bridge. And here you can see the glass fiber reinforced polymer bar reinforcement used in the top and bottom reinforcement. And in 2011, in Miami, Florida, 3.9 kilometer of glass fiber reinforced polymer bar were used in railway plinths for airport link, and glass fiber reinforced polymer bars were selected because they provided electrical insulation in the railway bed. So the seawalls constructed with glass fiber reinforced polymer bars are used in aggressive salt environment to provide long-term service. And an example is the seawall that provides the protecting the highway in Mao. And this wall was first constructed with a steel bar in 2001, but it required replacement in 2011. So you can see here this wall was first constructed with steel bar in 2001, but after 11 years, it was replaced with the GFRP bars because of the corrosion of those structures, which was built with the steel bar. GFRP bars are also found on the large and high volume traffic bridges, and in 2013, I-635 bridge deck over the State Avenue in Kansas City were replaced with the cast-in-place glass fiber reinforced polymer bar. And the construction bid for this project were the same for installed cost of the epoxy coated as well as the GFRP reinforcement. So I am going to talk about a case study where we compare where a deck slab was constructed with one side was constructed with a steel bar and the other side was constructed with GFRP bar, and both are compared in terms of their after the when the traffic load was applied using a truck and what kind of strain they generate. So the first bridge in Canada that was constructed using glass fiber reinforced polymer bar in concrete deck slab of one full span was Coxier-Eton Bridge in Quebec, and one full span was reinforced with glass fiber reinforced polymer bar, and other was with galvanized steel bar as shown in the figure. And bending moment in the bridge deck slab were calculated using Canadian Highway Bridge Design Code, and the top and bottom design moments were equal. However, the glass fiber reinforced polymer bar requirement were different. So the construction of the bridge started with building of a temporary bridge for traffic detour and demolishing the old bridge. The bridge was constructed in December 2003 to January 2004, and therefore the transportation on site storage and installation of the glass fiber reinforced polymer bar as well as concrete casting and curing were done in a harsh environment under the snowfall and low temperature between -10 and -20 degrees Celsius. The figure shows the snow removal, GFRP reinforcement casing and concreting of the deck slab. So after casting, the bridge was provided with a heating system, which required covering all the bridge with plastic sheets and applying a hot air flow from external heaters to keep the temperature 20 degrees Celsius for about 2 weeks. So after 6 months, field test was conducted for service performance using calibrated truck loads. And here the figure shows the deflection measurements using one truck load and strain measurement using the two truck loads on the bridge. The strain measurement were similar in both the glass fiber reinforced polymer bar and steel reinforcement. And following figure shows the maximum measured tensile strain in the GFRP and steel transfer bar. The maximum measured strain in the glass fiber reinforced polymer bars were less than 0.2% of the material unlimited ultimate strain capacity, which is much lower than the allowable strain limit in the ACI 440 of the 14% of the material ultimate capacity of the glass fiber reinforced polymer reinforced concrete structure exposed to earth and weather and subjected to fatigue. The maximum deflection of the concrete girders were measured at section G as shown in the figure. The deflection of the bridge deck slab were well below the Canadian Highway Bridge Design Code allowable limits, and the maximum measured deflection for the concrete girders and slabs never exceeded 4 millimeter throughout the test. So everybody's want to know about the cost. What is the cost of the GFRP bars against the steel bar? So here there is an analysis was conducted. So the expected savings when using the glass fiber reinforced polymer reinforcement, the expected savings in periodic maintenance and repair life cycle costs over steel reinforced concrete deck slab were not considered in this analysis. So the total cost of the bridge was 1.1 million Canadian dollar, and the assumed length of the glass fiber reinforced polymer bars were 2,250 meter of the number 16 GFRP bars and 7,907 meter of number 19 compared to the 18,000 kilograms of number 15 galvanized steel bar. So in 2003, the cost of the glass fiber reinforced polymer bars was approximately 80% more than the cost of using galvanized steel bar that I am talking about in 2003. It's already 20 years and now we have a lot of competitions. So the cost of the GFRP bars nowadays are very, very less, which is not higher. At that time, it was very high because the manufacturing plants were very less. But now we have a lot of manufacturing plants. The cost is reduced. So, however, when reinforcement costs are viewed as a percentage of total bridge cost, the actual increase in overall bridge cost with glass fiber reinforced polymer bars was only 2.78%. So in 2003, the exceeded amount was only around 3% than the steel bar. So these are the some of the different types of construction materials which are available at the SFTec bars. And here I want to show one video which will show they just is the number. This is the SFTec glass fiber reinforced polymer bar, and it was only the elastic modulus of the bar was only 40 gigapascal. So in conclusion, due to many advantages of the FRP bars over the steel bar, it can be used in many civil infrastructure projects like bridge deck slab, seawall, mining, tunneling. And with the advancement of the new ACI 440.11 2022 code, it can be also used in the buildings. The effective use of fiber reinforced polymer bar could significantly improve service life of the structure in harsh environment while minimizing the maintenance cost. And due to the better strength and lightweight and long service life, the glass fiber reinforced polymer bar as an internal bar has a good future in the concrete structure. So these are some of the design codes. The ASTO 2018 is used for the bridge design, and the new code ACI 440.1122. This is the building code requirement for the structural concrete, which is just released in this year only. And the other two are the Canadian code for the bridge and building design. So thank you for your attention.
Se escucha bien.
¿Escuchan el audio?
Estamos viviendo una de las mayores crisis
Afirmo.
del marítimo de la historia. Varios factores
El
se han
audio del video, ¿lo
juntado para
están
crear
escuchando?
una tormenta
Sí.
Afirmativo. Vamos.
perfecta en el comercio mundial que ha provocado escasez de algunos productos y un incremento de precios.
¿Por qué colapsado este edificio en Surfside? Este colapso que ha resultado tan dramático. ¿Qué opina usted? ¿Qué pudo ocurrir en este edificio?
Bueno, las cabillas es como cualquier metal que está especialmente al lado del océano. Están los diferentes cloruros en el aire. El concreto es básicamente poroso y a través de esos huecos entran los diferentes óxidos y entran los cloruros que hace que la varilla o la cabilla se corroa, así como se corroen los automóviles o una silla de acero que tú tienes afuera cerca de la playa. Ese acero al corroerse expande y puede expandir hasta 7 veces su volumen original. En conjunto con el concreto que se va deteriorando a raíz de que la varilla adentro de acero se esté corroyendo y rompe el concreto, eso para mí es el sospechoso número 1.
Entonces aquí lo que tenemos es un asunto relacionado principalmente con lo que yo considero es o representa el más importante valor de esta varilla en el mercado, en el mundo, que es evitar a toda costa la corrosión y los efectos nocivos que la corrosión contrae o conlleva a posterior, como tiene que ver los gastos en mantenimiento, ¿no? O incluso, como vimos lamentablemente, esta caída de las torres en Miami, lo que acaba de pasar en Mérida, precisamente con el muelle que se cayó, en las construcciones después de estos 50, 60, 70 años de haber sido edificadas con varilla de acero corrugadas, pues evidentemente van deteriorando la estructura interna de las edificaciones y por ende con el paso del tiempo se terminan colapsando. Y la única manera de evitarlo pues es hacer mantenimientos periódicos sumamente costosos. Esta varilla resuelve el problema.
Entonces, ¿dónde se fabrican estas varillas? Bueno, pues tenemos aquí al presidente de la compañía SFTec Canadá. En Canadá se diseña, se desarrolla toda la tecnología relacionada con este producto, se fabrican en China, en la empresa Shandong Safety Industries. Ella es la empresa líder en el campo de industrias de varillas de fibra de vidrio. Entonces, SFTec lleva a cabo su trabajo tecnológico, de desarrollo tecnológico. Se efectúan pruebas continuas de mejora de productos en colaboración con instituciones y universidades líderes. Adelante, Luis Alberto.
Sí, no, perdón, adelante, sí, no te interrumpí sin querer, disculpa.
Sí,
Adelante.
correcto. Yo, con esto yo comento también, no sé si en este momento Tufik quisiera hacer alguna aportación, ya que es el presidente de SFTec, relacionado con la empresa como tal, SFTec. Yo puedo traducir esto brevemente. Tufik, do you want to do something, express something about the SFTec and how does it work? How is that you develop the technology there, and then how is the condition that you agree with China to make these bars manufactured?
Yes, thank you to both of you for the opportunity and to everybody for listening here. Yeah, Chen, our CEO and president, has been working for the past more than 10 years, 12 years, with Shandong Safety Industry to develop that product.
Chen Wenxe es el director general de SFTec México en la parte tecnológica. Él tiene ya 10 a 12 años de desarrollo tecnológico con este producto. Adelante.
Now, Shandong Safety Industries is one of the top 3 leaders in China in this industry.
La empresa que manufactura en China es una de las 3 más importantes empresas de manufactura de este producto en el mundo, Shandong Safety Industries. Ok, adelante.
Now, Chen moved to Canada with his family and completed his second PhD. He is also an engineer. Sí. And has been working on developing the material, the FRP product, to make it one of the best in the world.
Chen Wenxe se muda con su familia a Canadá, termina 2 doctorados sobre de ingeniería y desarrolla todo este producto ya estando en Canadá.
So we've been operating here in Canada, in Montreal, for the past 4 years now, and this product that we've been developing goes with the American and Canadian standards.
El producto empieza a conocerse a través, bueno, SFTec saca al mercado su producto hace 4 años. Está aprobado por los estándares más altos en Estados Unidos y en Canadá, efectivamente.
Yeah, the factory in China produces 2 types of products, one completely dedicated to the Chinese market, and the other one, which is SFT-Bar, that is dedicated based on our standards and our requirements for the international market.
En China se producen 2 estándares relacionados con este producto. Uno es para el mercado chino completamente y otro es el que se desarrolla para SFTec en Canadá.
Sí, no, en este caso que es la planta de China provee el mercado local chino, asiático, y que SFTec se concentra en las ventas internacionales.
No. China, la planta de China, efectivamente, produce para el mercado chino lo que el mercado chino, pero produce en particular, de acuerdo a la tecnología y los estándares de SFTec, el producto para SFTec. Es decir, es un producto específicamente diseñado, sellado y certificado para SFTec.
Yes, trademarked SFTec.
Correcto.
Yeah.
Sí.
That's it.
That's it. Okay.
For
Muy
now.
bien. Thank you.
Yeah.
Thank you very much. Los diámetros y longitudes de las varillas exactamente los mismos. Se manejan las longitudes de 6 y 12 metros, un poquito más cortas, 5.85 y 11.85 por las logísticas del manejo del material en contenedores de 20 y 40 pies respectivamente, pero como les digo, los traslapes son más cortos, no se pierde material en realidad. Todos y además también podemos hacer diámetros y longitudes a la medida o a solicitud del cliente. Esto es muy importante. Nos preguntaban en la expo, ¿qué más pueden hacer? Pues dinos qué necesitas que hagamos. ¿Pueden hacer varillas lisas? Sí, las podemos hacer. ¿Pueden hacer varillas de tales diámetros? También las podemos hacer. No sé si, ingeniero, usted tuvo la oportunidad de ver unas varillas huecas que se pueden utilizar. Hay muchas aplicaciones para estas varillas, pero
Quisiera hacerles una sugerencia, toda vez que mis compañeros no conocen las varillas, solamente dijeron Norman Castro, García Castro y su servidor que estuvimos ahí en el Esposia con Tufit, si las vimos, no sé si pudieran mostrarlas o unas fotos ahorita
Ok, con
para
mucho
que las
gusto.
pudieran ver
Tufik, do
mis
you have
compañeros.
pictures of the samples you brought to the Exposiac? Because no, not all of them saw them. Just the Ingeniero Lopez and another engineer. So they would like to see them. No.
I can show now on my screen if you want.
Okay, please.
Yeah.
Okay.
But also they can refer to our website. This is the 15M.
Okay.
Your typical 15M, and this is the typical color.
Yeah.
Okay. Okay.
Now,
Can we see it in front?
As Laura mentioned, they come in 6 or 12 meters minus the 15 centimeters for the door of the container.
Yes,
Lo que
okay.
nos explicaba la ingeniera Laura es que estas varillas casi miden 6 metros, quitándole unos centímetros para que puedan caber dentro de los contenedores, ¿no?
Ahí tienen ustedes una varilla de otro color, como les digo.
We can color them if you need colors.
Yeah.
We can just add coloring if you have a reason for it. It doesn't cost anything more. Just we can add it.
Nos dice el ingeniero.
Pueden proporcionar varillas de diferentes colores sin ningún costo adicional. Es de notar, él nos lo comenta esto, que la varilla, que este es más bien un tubo con rugosidad en la parte exterior. Can you show the section? Yeah, the transversal section. Yeah.
Now, this one here has a hole.
Yeah.
Okay. Some applications need them. Not most of them don't, but some applications in mines and in tunnels need with the hole. So we have the capacity to make them with the hole.
Okay, entonces lo que les respondimos hace rato, no todas las aplicaciones lo requieren, pero las tenemos.
Your typical bar is not going to have a hole unless you ask for it.
Exacto.
Can you talk about the corrugation, the size of the corrugation? You can see, ustedes pueden ver que es perdón, me iba de largo, pues ustedes pueden ver que es una espiral prácticamente. Él la está rotando para que se pueda ver, ¿sí? No es la típica corrugada, el típico corrugado que tienen las varillas de acero.
It's better for the with the concrete, for bonding.
Okay, es mejor para el trabajo con el concreto.
Dice que ese tipo de corrugado es mejor para la adherencia con el concreto. Y aquí nos está mostrando un perno de anclaje. ¿Ya? Se fue a traer una gran cantidad.
Sí, sí. Esta es una varilla que se utiliza para la industria, para la agroindustria, como ustedes ven, entre otras aplicaciones. Pero de esta forma se puede clavar. Son conectores, exactamente.
Son paneles ensamblables.
This is the height of the perfil, 12 of 40 millimeters.
From 12,
only?
We have all of those millimeters, yes, from 12 to 40.
Yeah, but it's not diameter, no, it's size.
Size,
size,
excelente. Es buena observación. Es un tamaño, exacto, desde 12 milímetros a 40 milímetros, efectivamente.
Ahora en español se los pregunto a ustedes, ¿el tamaño máximo del perfil son 4 centímetros, 40 milímetros? ¿Eso es todo?
Yes, because it's not round. We should change the word diameter, you're right.
¿El tamaño máximo en altura?
The maximum height of these bigs, how is it?
It's 12 to 40 millimeters. But the length, how long it is, we can customize it.
Okay, but you can customize also the height?
Yes, if they want, yes. Between 12 and 40.
Entonces, 12 and 40.
8 inches or, yeah.
Yeah, I mean, I don't know the difference, the calculation between millimeter and inch, but it'll be within what you need.
Ok, ingeniero, sabe, creo que estamos teniendo un malentendido con estas vigas.
Sí, a mí me
Yeah, I
gustaría.
Entonces,
see what he wants to do with them.
sí,
Yes,
sí,
we can do these things probably. Yes, just
sí,
send
creo
us the
que
send
sí.
us the specifications and I'll get back to you also on the pricing for it.
Exacto. La respuesta en general después de este momento es, ellos las tienen, arquitecto, porque usted estaba preguntando si las tienen, las pueden fabricar, las fabrican de acuerdo al tamaño que ustedes requieran, no importa si es largo, ancho, alto, las fabrican. Entonces, hay un error ahí con lo que acabamos de ver, con la imagen, hay que corregirlo, pero efectivamente pueden fabricarlas, efectivamente pueden cumplir con las cuestiones arquitectónicas para las cuales usted visualiza este producto.
And yes, we can add colors to them.
Y también se puede agregar colores a esto. If we place a purchase order, a big purchase order, let's say 10 containers, 10 40 meters, full containers,
Okay.
will it take like 2 weeks, right, in the manufacture?
It depends on what you're ordering, but
I mean,
usually a typical order takes, if it's only straight bars, it can take up to a week, and then if you add to it a lot of bends, it will add an additional week.
ok, entonces normalmente cualquier tipo de orden va a tomar una semana si son barras en la manufactura y una semana más para todo lo que son perfiles. Entonces en 2 semanas llega su proyecto completo, sale de producción su proyecto completo y se embarca.
In terms of 10 containers, let's say it's 10 containers of 25 ton, that's 250 tons. That's a
Ya,
lot of bars. So I wonder if they will need them all at the same time or there will be a schedule. So
ya,
we
entonces,
will have to understand that and then we'll produce accordingly.
ok, vamos a entender algo aquí que es muy importante, ingenieros. Esto es súper importante. En un contenedor, regularmente, donde se pueden cargar 21 a 23 toneladas de acero, el contenedor no llega lleno porque el contenedor sufre, se puede dañar. En el caso de esta barra, oigan esto, es espectacular, yo estoy realmente con este dato, es increíble. En el caso de estas varillas, sí llegan completos. Eso quiere decir que si usted había pensado en comprar un contenedor, un full container de acero donde le van a llegar 23 toneladas, 21 a 23 toneladas, pero el contenedor no llega lleno, en nuestro caso, esas 21 a 23 toneladas llenan el contenedor. ¿Qué quiere decir? Que si usted esperaba un volumen de material de 23 toneladas, aquí le va a llegar un volumen de material aproximado de 80 toneladas.
No, habrá que investigarla, pero recuerde que expliqué que la varilla es transparente completamente a las cuestiones de este tipo de...
Magnetismo. Ujú.
Ajá, entonces normalmente un escáner infrarrojo usa ondas electromagnéticas estilo radar, donde van y vienen y detectan la ubicación del metal dentro de la estructura de concreto. Si aquí habláramos de una casa, un puente, una edificación donde ya construimos la obra con varilla de fibra de vidrio, el escáner que se usa para el acero no necesariamente va a poder leer la varilla de fibra
Es
de vidrio
correcto. Sin
por las
embargo,
características
fíjese,
que tiene.
entonces, ¿cuál es la diferencia en costo en comparación con el precio del acero en México? Este producto, y esto es muy importante también, debería ser comparado en costo con el acero inoxidable. Nosotros estamos comparando nuestros precios con el acero regular. Por supuesto, con el desplome de los precios del acero en las últimas semanas, nos hemos castigado muchísimo para seguir ofreciendo entre un 3 y un 7% por debajo del precio público del acero. Las fluctuaciones del dólar, las fluctuaciones del precio del acero, a veces nos dan más, a veces nos dan menos. Hace unos 2 meses podíamos pensar en por encima de un 10 hasta un 15% por debajo del acero.
En
Pero ¿qué
marzo,
me estoy, en marzo, con qué me estoy encontrando? Las personas interesadas dicen, no, pero es que ahorita está casi a la par del acero. Digo, a ver, estás adquiriendo una gran tecnología que debería estar dignamente comparada con el acero inoxidable porque lo supera. Te lo estoy ofreciendo a un precio menor que el acero regular. Yo no quisiera que esto pareciera algo barato, algo que, pues es plástico, no es plástico, no es plástico. Es un gran producto a un gran precio, porque lo podemos hacer así el día de hoy. Este producto hace unos años costaba 9 veces más que el acero. Esto creo que es importante para todos, puesto que es un producto que porque finalmente hay que pagar, pero que va a traer grandes ahorros si es que se compara con el acero. Pero si aún el producto llegara a estar a la par del acero o 1 o 2 puntos por encima del acero, va a ser siempre mucho más económico que el acero inoxidable, que cualquier otra solución que se quiera poner contra la corrosión.
Por ejemplo, ustedes pueden ver esta imagen donde
Claro.
se pueden ver las varillas de diferentes colores, ¿sí?
Ujú.
Y que permiten tener una idea bastante clara. Se ven los conectores aquí, por ejemplo, o cómo están anclando. Esto obviamente tiene casetones, pero bueno, esta es por eso la idea, ¿no? Y
Ujú.
bueno, no sin darles muchísimas gracias a ustedes, agradecerles mucho el tiempo dedicado y la información que nos están compartiendo. Indudablemente, pues esto es importante que lo conozcamos todos, lo discutamos, de verdad es mucho, muy importante, ¿no? No,
Muchas gracias.
nadie habla. Bien, pues muchas gracias. ¿Sí?
Muchas gracias.
Al contrario, gracias a ustedes.
Entonces,
Muchis-
nos reunimos ah,
El día 29.
el día 29, martes 29, igual a las 10 de la mañana, ¿no?
Sí, muchas gracias,
Sí.
ingeniero López. Muchísimas gracias por su amabilidad y su confianza, sus atenciones y la de todos los ingenieros y arquitectos que el día de hoy nos han acompañado. Gracias, Tufik. No sé si ya se frizó la imagen, no sé si está por ahí. Gracias
Sí,
por tu
aquí está.
compañía. Aquí está,
Ya,
ok.
ya.
Tufik, thank you very much.
Yo solo, igual, agradecer, pero sobre todo poner el punto sobre el énfasis de lo que significa que el Instituto Mexicano del Petróleo, ingenieros, hoy esté presente con este tema porque se caracteriza por esta investigación, por esta seriedad con la que hacen su trabajo, que es un aval muy importante para las empresas estatales y también privadas. Me parece que también este cruce de caminos con tecnología, más el conocimiento que ustedes desarrollan, siembra un precedente, una medalla, un reconocimiento más para lo que el instituto puede desarrollar como investigación. Llevaría su sello, pues, el hecho de que pudiéramos avanzar colaborando con ustedes, estamos completamente abiertos, porque para nosotros significa un aval importante, pero para el instituto significa una más de las muchas cosas que están haciendo por innovar en el país. Así que yo les agradezco y los invito a que estén abiertos, que colaboremos y estamos pues en la mejor de las disposiciones de brindarles toda la información que requieran. Muchas gracias por todo, por su asistencia y estaremos en contacto muy pronto.
Just a quick one. Raul Chavez asked a question about detecting fiberglass. I've answered that in the meeting, in the chat. It cannot be, but we can add some carbon in the formula so it can become detectable if it is important for you guys. So it's not a big deal. We can add that. But in theory, it's not yet detectable because no machine can read it. It's not like the steel.
Yeah.
Okay. And thank you very much to the Institute for organizing this and for your interest in the product and with our products and SFTec and CAVINSA. And thank you for Laura and Luis for all the help. Much appreciated. Thanks a lot.
Thank you, Tufik. Muchas
Many
gracias.
thanks for both.
Gracias, gracias. Solo antes de despedirnos, creo que es muy, muy importante para el ingeniero que hizo el favor de extender esa pregunta. ¿Se puede agregar carbono a las barras para poder detectarlas? Excelente. Muchísimas gracias.